Hey, well, thank you for coming to my talk. My presentation is on building how to build an indoor testing infra. I'm a GDE in Kotlin and Android, and the context for this talk is that I worked on one of the projects I worked on as part of a platform team is to figure out all the pieces that you need to put in to be able to test different things, and uh, and that's what I'll go over. So what I'll cover in this talk is how do you do testing in terms of automation? How do you build an infra pipeline and test like snapshot testing with Gradle? So suppose that the challenge that you have is that you're working on a team that's contributing to a monorepo continuously. And in that case, you need to be able to make sure that you don't have any regressions. And manual testing doesn't really scale. And you also may be in a situation where you have a fragmented code base and you have different areas of your code base where you have legacy code and you want to refactor it. You want to make sure also you don't introduce regressions. So you want to put in some testing infra in place to make sure there aren't any regressions introduced. Another problem is that as you may have different areas of the code that have different test coverage, and introducing patterns is really important to be able to get more test coverage in. So, and another final problem is that Android testing is not just about UI testing; it's also about you can have failures in terms of your database migrations or you can introduce regressions in terms of your Gradle builds. You upgrade something, but now your Gradle builds are slower. How do you detect that first? So these are the three goals. So what I worked on was planning out how you automate and scale and be able to test different things. My goal was not to write the unit tests myself, like get 100% coverage. It was about putting in a scaffolding in place so that feature teams could iterate and add more tests for their work. So I want to start with UI test automation. And suppose you're in a circumstance where you have lots and lots of tests, and they're usually written by software developers and test. And suppose you had a full suite, and the problem is that you wanted to figure out how do you run these tests, how do you run them in parallel, and let's look into that. So I want to go through each of my test cases and run them on some device. And what I could use is Firebase Test Lab. And what it provides is a set of devices with different API levels that I could test on. And there's a tool called G Cloud, Google Cloud, that you could use to upload your APKs to Firebase Test Lab, and it integrates really well with CI. So how do you use G Cloud? So here's the command line. So it's through the command line, and this is a command where you can list out what are all the devices that are supported, and it will display either virtual or physical devices. And what's this is really helpful when you want to find bugs in like lower OS levels and with different resolutions on like older devices. So there are different types of tests that you could run. There are instrumentation tests and there are robo tests, and we'll look into both of these. So when you run instrumentation tests with G-Cloud, you provide an APK, and then you would also provide like a list of devices that you want to run the test on. So the way this works is that underneath the hood, it uploads your APK to Google Cloud Storage, and it takes it from there, and then it uploads it to Firebase Test Lab, where it goes through and runs all of your tests. And then the result is given back to you in Google Cloud Storage that you could pull. So what does a report look like? So here's an example of a test matrix of a report in Firebase Test Lab, and it has the ability to take video or screenshots for any of your UI tests, and and you could run this on different devices. So when you go into Firebase Test Lab, you'll see this running. So the G Cloud, what it does is it creates this test matrix. So the other type of tests are robo tests. So suppose you're starting out and you don't have any test coverage at all, but prior to your release, suppose you did a release cut and you want to find some get some test coverage. And robo tests, what they will do is that they will crawl through your app in different navigation links, and then they will also take a screenshot. So this is an example of how it looks. It creates a call graph right here, and it will, for example, like start a screen or go to another activity. And this is helpful to make sure, like when you go to a certain page, any navigation link in your app, it doesn't cause any exceptions. And so this is a good starting point, adding robo tests. So in your CI pipeline, whether you're using Jenkins or Circle CI, you could set up different stages where you build the APK and then you use G-Cloud to upload it and get a report. So as you're adding more and more tests, one of the problems is that how do you run, when you have lots and lots of tests, how do you run them in parallel? And how do you do that? So there's a tool called Flank that you could use. And this is by Walmart Labs. And this tool allows you to run tests on Android and iOS. And it was recently rewritten using Kotlin coroutines. And this is a great tool to use. Many companies use this. So what it is that it allows you to easily configure what devices that you want to run your test on. So you specify a YAML file in your repo, and you specify what devices that you want to run your test on, but you could also specify the number of groups that you want to run in parallel. So for example, suppose I want to break apart my test to have two tests run on one set of devices, another set on another devices. So you could run tests in parallel, and you could do this by specifying a number of shards you want. So in this case, it's 2, could be any number based on your use case. So that's really helpful to run your tests in parallel. You could also specify, like, I want to specify a threshold, the number of time that it should take. Like if it takes more than 2, for example, 2 minutes, then I want you to fail. And that's helpful when you have flaky tests, for example. So the way you run it, if you were implementing this on CI, is just doing Flank Android test run, and that will read your YAML file, run your test in Firebase Test Lab. So, and it will run them in groups of 2s. In this case, with 2 shards. So, and the result for all those shards, there you could be merged together, and then you could upload that to some central repo. So one of the problems you may encounter is that UI tests are really flaky, and there are different strategies to handle them. And flaky tests could occur when you have concurrency problems or third-party code, or you have resource idling. So there is a way you could specify, when you have flaky tests, you could specify a retry count. I want to retry twice. There's also another tool you could use by Gradle that allows you to specify different behavior you want for like number of retries or thresholds for flaky tests. So the way you could set this up with Flank is that you could create a Docker image. So if you were using Flank locally, you'd have to install it through Brew, which is package manager. You could create a reusable Docker image that has Flank installed, and then you're reusing it. So Circle CI or Bitrise, and they have integrations for this. And this is something that's really helpful. So another tool, suppose that you didn't want to like create a Docker image, you wanted to run a Gradle command. There's a tool that you could use called Fladle, which is a tool that as a wrapper around Flank, and it provides you a Gradle task that you could run, and it has multi-module testing support. So what you could do with the Fladle is that you could break apart your test into like Suppose I want to run my regression test on a set of devices and run my performance tests on another set. And I could group things together with Plato like this. For example, this was for running your performance test, and this is for running your regression test. So Plato gives you it's a great way to, if you want to run a Gradle task, have a Gradle wrapper around Flink. So we looked at how to set up a CI infra for that, but when do you run these tests? Though there are different approaches you could take, and the goal is to like take out like manual testing that QA engineers would have to do, and and you could run these UI tests nightly, these regression tests, and get a report. And another way that you could do it is you could also run those you could also run these tests as part of like when you do a release cut, and then you want to do some regression testing. That's also when you could run them. You could have a standalone CI job that does that. So something else you could do, there are tests that you could run that could be part of your PR, which are called smoke tests, and they're basically tests that test basically basic functionality, and they're not something that's complex. They're easy, simple to run, and you could in your test suite differentiate smoke tests by using an annotation. So that's a power pattern to follow, and set it up so that it picks up all those tests to run. So a good example of this is the Firefox app, which is open source. So everything that I just shared, that setup, like the Firefox app, is a good example of it uses Flink. It has smoke tests, and here's a repo called Phoenix, and Firefox uses Rust. So anything that uses Rust is good. So the way it sets up, the way the Firefox app sets up like a pipeline is that when it runs your tests, it uploads them to something called test rails, and that's a type of tool that allows you to collaborate with QA engineers. So it's a tool where you could look at in an in an automation, like what was the result, and if a test was flaky, the QA engineer could go back to your developers and then share what went wrong, share its stack trace. So here's an example of the Firefox app. It uses test rails, and you can see that it has broken apart the tests in different sections like onboarding, home screen, for example, and it also has smoke tests. And in here, you could see over time, like what were the tests that, what were the results over time for each release, and the tests that were run. And then when you go into one of these tests, it shows you what device it ran on and the steps. So this is something that's really helpful to set up for QA engineer. Test trails is you could create an internal server and set up test trails on it. So that's something that I found really collaborative. It's something really helpful. So we looked at the basics of tests, running UI tests in parallel, and how to handle flaky tests. So now let's look at unit testing. And it's important to add unit testing because they're cheaper and much more reliable. So when you look at what I'll share is there are things that you would consider to be integration tests, like like for example snapshot testing. There are tools that allow you to do it at unit testing level, and I'll share them. So how do you go about, I worked on one of the apps I worked on in the past didn't have a lot of unit tests, and I had to come up with patterns to share with feature engineers on how you would structure your unit tests. So how do we structure our unit tests? And one of the, so suppose you had a presenter that you were trying to test, and then you could be a view model, an Android X view model, and you're injecting dependencies. You could use mocking or fakes, and with mocking, I worked on code bases that used mocking a lot, and it was hard to read the code because it used things such as argument captors, spies, for example, and readability is something that's really really important, and it did a lot of magic underneath the hood. So I always opt for creating fakes. So to create fakes, for example, what you could do, for example, is create an interface. Like in this example, you have a repo that gets data. So where do you place this? Where do you place basically the actual implementation, the fake for this? So a structure that you could follow, if for example, is well, what structure you follow is dependent upon your use case, but here's an example where each of your features are folders. And in there, you have different modules like public, impl, fakes. So public, you would have your interfaces. And then impl, you have the actual real implementation. And then you have your fakes in your fakes module. So you could break apart your features like this, have all your fakes in one of your in a separate fakes module. So this is something really helpful in terms of structuring your code, your test code, and your actual implementations. So then you could create a fake repository, inject into your presenter. So as you start to have use this pattern, you want to be able to create some dev tools around it. Like someone builds a feature and they're going to add tests in there, the actual code, you want to create some form of a script or a plugin that could manually that could generate all the scaffolding out. Otherwise, people will copy from one feature to another, and they'll have unused dependencies. You could also, as part of a Gradle plugin that you could create, you could enforce rules in. If you had like multiple features, then what are the rules on how one depends on the other? Like, does impl depend on another impl? And so that's something that's good. That's good to do, very useful to do that I find. So the other thing that you want to set up are like lint rules to enforce best practices. So, for example, I set up lint rules to prevent people from using spies, for example, with Mach-K and get people to use fakes. It's hard to enforce that by reviewing every PR, but building a tool really helps to automate things. Another thing is to set up coroutine test rules, and you could set up rules such as like providing an empty context, for example, and so there are a number of test coroutine test rules that you could set up, and another one that you could set up good practices like not mocking data classes. So a good example is that Slack has a repo called Slack lints, which has a lots of examples of these types of lint rules that you could use. And so as you add more and more unit tests, one of the challenges becomes is that running them all it takes a lot of time. And how do you run unit tests? Only the ones that have been affected as part of a PR. So suppose that you were basically on a branch, like, and you were working on like a person worked on updating different files and different commits, and you need to figure out like what unit tests were affected. I only want to run those. So as part of your CI pipeline, what you could use is a tool called Affected Module Detector by Dropbox. And Dropbox has really great Gradle plugins, such as, for example, Focus, and they have Dependency Guard they just released. So Affected Module Detector figures out based on your commit like what was changed. And one use case that you could run this on is to run only the unit tests that were affected. So the way you structure this is that in your root module, you specify how you want to do the comparison. So for example, in this case, I want to do it based on a previous commit. So you could also specify with a fork commit or specified branch commit. So what you would do then for each of your submodules is that each of your submodules has a task they could run. It could either be Android debug or test debug, or you could have it with flavors like test internal debug. And affected module detector, you could tell it that I want you to run one of these tasks. So affected module detector supports both Android tests and also like unit tests. So what you could do in your CI pipeline when they get run as for a PR is to run this task that this Gradle plugin gives you. and run effective unit tests, and it will basically figure out what unit tests to run, and it will run only a subset of them. And the same thing you could do for your UI tests. So that's been really, really helpful to like cut down on the time that the PR takes to run. And that's something useful to add at this step of your CI pipeline. So the other thing that I want to share is there are other types of tests that would be good to move towards unit testing. And one of them is snapshot tests. And setting up snapshot tests is a challenge. So snapshot testing is a challenge, and the problem that comes up is that suppose that you made a change to a layout file. A developer made a change and it was using a constraint layout, and there was an error and a problem in there, and it caused a regression. Basically, the change after it was committed, it was found, and usually, how do you prevent those types of things beforehand? So there's a tool that you could use called Paparazzi. So I work at Cash App, and I use this tool and Paparazzi, and it's just a Gradle plugin, and what this is that this Gradle plugin, it utilizes something called Layout Lib. Layout Lib is a library that's used by Android Studio to render like your layouts, and it leverages that to be able to generate a rendering of it could be either XML or Compose, and recently it supports Compose UI. So the way you use Paparazzi is that you could set up a rule in which you specify like under what device config and theme that you want to run this in. And then you go, and the next step is that for a test. So in this example, I'm doing paparazzi.snapshot, and UI view in this case is a composable function, and is my view, and I could pass in some UI state in there. So then what that will do is render a snapshot. So you could then like change your UI state and render different types of snapshot based on what your UI state is. So the way you need to set up Git LFS, like large file system, because it has to store your snapshots. And at Cash App, we have basically a way to view all your snapshots, all the current and existing snapshots that were generated. So, and how do you set this up like in your pipeline? So what Paparazzi gives you are two tasks. One is to record your snapshots, and the other one is to verify them. And when you run this command, what it will do is that it will verify it against a previously recorded snapshot. And this has been really, really helpful for us, and we use this a lot for a lot of our features, Paparazzi. So another problem so Paparazzi, the biggest advantage is that you're doing it as part of your unit test, and it's much more reliable. And the other problem that commonly happens is unit testing your database migrations, and how do you move that towards your unit test? So, and this is a common problem that I found at one of my previous jobs, where a lot of things would break if the schema of a database changes. So suppose you had a database. Suppose you had an app that cached things to the database, and you may be using Room or SQLite. And suppose, for example, suppose you had a users table in your database, and you had a column that you wanted to rename from user email to email. And how do you set up this type of a migration? So suppose you were using Room, and Room added the ability to set up auto migrations. And the way you do that, you can specify like rename column, delete table, so they have simple support for all those things, and where you don't have to write out the SQL query yourself. So whenever you set up a migration, you set it up you're going to go from one version to another. And this is where the problem could come in when you have multiple migrations. And how do you test each and every one of them or all of your migrations? So how do we test migrations with Room? So Room provides you with extensions and with a lot of utilities. And for example, migration test helper, where you list out all the migrations that you want to test, and and then you specify it as an annotation with rule. Here's an example of a migration that you could set up where you create the database and you specify with a SQL query what data you want to insert, and and you can't use DAOs and that execute like SQL. You can't use DAO and that apply a block. And then you would run a method to run your migrations, run and validate. And these you can run one or multiple of them, but one of the challenges is that these are Android tests. And so how do you run them in your unit tests? So with these migrations, you could verify, you could perform a query, get a result back, and perform assertions and verify against them. So how do you do these test migrations how do you do these tests with unit tests? And there are ways you could provide a JDBC SQLite driver, for example, with Room. And that allows you to test like with unit testing. And one of the libraries that I use is called DB Tools Room for Android. And that has a lot of utilities to be able to do this. So here's the URL for this library. And what it does is that it provides you with a lot of extensions to be able to work with Room. And what this provides is a base migration class that handles creating the database and performing a migration and testing it. So you would set, with the way this works is that internally it sets up a Room database that has a JDBC in which you provide a JDBC SQLite open helper factory. And then you will run basically your migration by using this extension, create the database, and then run migrations and validate. So that's the simple way, and you can specify one or many migrations. And the benefit is that you could run it it runs as part of your unit test. So those things are really big because you could be working on features and upgrading, like changing your database, and putting in those little pieces really help to get feature developers to write tests on top of an infrastructure. So, but that's not the only thing that could break. And one last thing that I want to talk about is Gradle. So what I have worked on a lot is, as part of a platform team, is improving Gradle builds. And your Gradle builds, they could break for a number of reasons. Someone could upgrade Gradle version and your configuration cache could break. And how do you set up your testing infra for that? So how do you detect build regressions? And one tool that you could use is called Gradle Profiler. So suppose you had a scenario where you were working on a repo and you were modularizing it, or you were like attempting to upgrade Gradle version, and you want to figure out what is the impact that this going to have. And the way you use Gradle Profiler is in two steps. You write a scenario and you specify a number of iterations that you want to run this Gradle Profiler on. So, for example, you could specify, I want to run 3 iterations, in which each iteration I want to do something called an ABI change. ABI stands for Application Binary Interface. So you could specify that I want you to run Gradle builds, and the change that I want you to make is in the API of certain classes, or it could be resources. So then you could gather the result. So here's an example performance scenario to test an incremental build. When I want you to run like 5 or 6 Gradle builds, one in each sequence, and one after the other. For each of them, I want you to perform an ABI change, so it could be some utility class. So you could be in a module where you're testing something in, and you're going to go into that module and say that, hey, I want you to test making a change to a certain class. You could also do this for resources in that module. You're going to specify which task that you want to run test on. You could also test your Android Studio syncs also. So when you could store this performance scenario as part of your repo, and you could have different performance scenarios that you could run like nightly. So the way you run Gradle Profiler is by, like, for example, you specify this command. So you would download this tool, Gradle Profiler, and say, I want to do 10 back-to-back builds. And I want you to test, gather the results from all those 10 iterations. So it will give you the mean, median, mode, and the different percentiles. And it will give you a graph like this that you'll see, that you could then determine whether what you did was good, whether it had some negative effects. So how do you automate this? So with the way you could automate this is that you could create like a standalone job with Jenkins or SQL CI in which you have a Docker image that you use that has Gradle Profiler. What if you were doing this locally? You would have to install Gradle Profiler either using Brew. So creating a reusable Docker image is something that's really helpful. And then you could run performance scenarios on that you store in your repo. So then you could also run this nightly. And this is running it nightly is something that's really helpful. When you run it nightly, you could store the data somewhere and then like create a graph to see the overall trend. And this has been really helpful, for example, with introducing Anvil. That's in one use case. So Anvil is a library that's could generate. You could use it to improve your build times, where you could use it to generate your Dagger factories using a compiler plugin, and you would go in and remove capt and then configure Anvil in your modules. And how do you test whether this actually gives you an improvement in your Gradle setup? The way you could do it is that you could basically run Gradle Profiler on a before and after. Before is without Anvil, and after is with Anvil changes, and compare the results. So, and here's an example like that you could create a graph of the baseline and what it looks like with Anvil and see and compare like the performance for each module. And this has been something helpful to me when I'm like introducing KSP for Room or introducing Anvil to see the performance impact for it. So that's my presentation. I hope that was helpful. I covered different ways to test your Android app and to be able to do different types of testing. And if you have any questions, you could ask me now, or you could DM me on Twitter. On my website, also have a lot of content on coroutines because I introduce them at different companies, and I have content on different patterns that you could use with coroutines. So check that out. Content on gRPC and Compose, and I want to say thank you for being here.